Hello and welcome back to another episode of Math with So. And today we're going to be doing transformations of any given parent function. Okay, so the first thing we're going to start off with is reflections. If it is reflected over the y-axis, that means that the original function went from here, and then if this is the y-axis, it would flip over to here. Okay, and in order to do that, all you have to do is make the b. You would have to change the sign of that and make the b negative. And there is the b right there in your formula. It doesn't matter if it's an absolute value, if it's parabola, or whatever function it is. If the b becomes negative, if the number in front of the x becomes negative, whoop, it flips over like that. All right? So, if that is the case, then how do we flip it over the x-axis? Well, in order to flip it over the x-axis, that means that the graph would need to be up here, and then it would need to flip over like that. So in order to flip over the x-axis, that means that we have to change every value of y. Okay, it would need to be a negative f of x. Okay, in order to do that, you would need the a to be negative, and you would need to change the k value. Okay, so essentially you're switching the value of the a and the k in order to flip it over the x-axis. All right, by technicality, if you want to flip it over the y-axis, it would technically mean that f of x is turning into f of negative x, where you change the value of x to negative x. If you want to flip it over itself, for example, if the graph was up here and you don't want to flip it over the y-axis, but you just want to flip it over itself like that, that would just mean that the a value is negative. Okay? Dilations. We have a vertical stretch. That would be when a is greater than 1. All right? And that would mean if your graph was looking like this, and now it is all of a sudden skinnier. Okay, so it's a little bit more narrow. Versus a vertical compression, that would be when the a value is smaller than 1, but also bigger than 0. Okay, so essentially if the a value is a decimal, that would be when your graph starts out normal, but then you compress it vertically, so it will be stretched out. All right, so technically speaking, visually, a vertical stretch and a vertical compression are the exact same thing visually as a horizontal stretch and a horizontal compression, but they'd be the opposite. For example, a horizontal compression would be as if you were to take your original and you would make it more narrow. Okay? So if you compressed it horizontally, you pushed in somebody's arms from hugging you, versus a stretch where you stretched the arms out horizontally, like so. All right? A horizontal stretch would be if you take the b value, and the b value is smaller than 1 but greater than 0, versus a horizontal compression would be when the b value is greater than 1. So that would be the b value right here. All right, so essentially if it's next to the x, it affects the x's values. If it's next to the y or the y equals, then it would affect the y values. That's more of a technicality. Visually, it does the exact same thing. All right, translations. This is one of the easier ones as long as there is no b. If there is no b, it is just change the sign, keep the sign. And if that happens, let's say, for example, we have y equals 2, x minus 3, plus 4, that would mean that it goes 3, 4. A lot of times we call that HK, and it would shift it to the right by 3 and up by 4. You change the sign, you keep the sign. All right? If there is a b value, for example, y is equal to, let's say, absolute value of 2x minus 6 plus 1, then your keep the sign is fine. This, you do not just change the sign. Technically, what you would need to do is change the sign and then divide by 2. So you change the sign of the 6, and then you divide by 2, and you get 3. Okay, so your actual vertex would be 3, comma 1. It'd be moving to the right by 3 and up by 1. Another way you could do it, rather than just saying change the sign and divide by 2, you can always just set the 2x minus 6 equal to 0, and whatever you get from that ends up being your value of the vertex. It's not a change the sign if you set it equal to 0. The setting it equal to 0 forces you to change the sign. Okay, so those are all the transformations, dilations, and reflections. Let's do some examples for them. Let's get it done. All right, so here we need to understand that the first dotted graph is the original parent function of f of x. We're going to write the new equation for g of x, and we're going to identify the transformations. This one just went to the right by 5 and up by 3. So right 5, up 3. And the new equation for g of x, it is an absolute value graph, so it's going to be a bars for that. Right by 5, up by 3 would be change the sign, keep the sign. Absolute value bar, x minus 5 plus 3. All right. Next one is not an absolute value. It is curvy, so this is going to be an x squared graph. So g of x is going to be an x squared as well. Let's put the parentheses in the squared. And this one went to the left by 2 and down by 3. It's at negative 2 comma 3. So left by 2 would be x plus 2. Down by 3 would be x minus 3. So far, we have not stretched, dilated, or reflected. We've just dealt with the transformations. But the next ones are going to do some reflections and so on and so forth. Okay? So here we have it right by 4, up by 3. So this is at 3 comma 4. It is negatively facing. Okay, so it could have been, this could be interpreted a few different ways. You could think of it as like, okay, we originally went right 4 and then down 3, and then we flipped it over and we did some other stuff. All right, but we're going to start with the fact that it went right by 4, and, right by 3 and up by 4, and then it just has a negative slope. So because it's flipped over itself, we're going to put a negative for the a value, and we're going to change the sign. We're going to keep the sign, and it's going to be x minus 3 and x plus, and the plus 4 afterwards, and the negative would just be here. For number 4, this one has a vertex of negative 2 comma 5 or 6. Okay, so it is another absolute value, but notice how it's a little skinnier. So this one is stretched vertically by a factor of how much? Well, it is going, it's kind of hard to tell, so I'm just going to go from the 6. It's going down by, from 6 all the way to negative 2, and then over by 2. Okay, so if it went down by 6 and to the right by 2, that is not down by 6, down by 8 and over by 2, negative 8 over 2 is stretched vertically by a factor of 4. Okay, it is flipped over itself. Because it is facing downward. So the equation would be y equals negative 4, because it's flipped over itself and it has a stretch vertically by a factor of 4. Change the sign, x plus 2, keep the sign plus 6. Okay? Moving on. These next ones, we are given the f of x and the g of x, and we're going to be determining the transformation and then sketching a graph of both f and g. So f of x is just an absolute value. That would be looking like this. It should have a slope of 1. And then g of x, we have to stretch it vertically, factor of 3. Nope, 2. It has to flip over itself, and it would be shifted up by 3. You could also interpret this as flipped over the x-axis, but then you would have to like shift it down by 3 before you flip it over the x-axis. So I like thinking of it as up by 3 and flipped over itself. Okay, so let's move it up by 3, 1, 2, 3. And flip it over itself means that the graph itself would just flip upside down from that moment. All right, that's all she wrote. Let's label it as g of x. Number 2, we got a parabola. So a parabola, we're going to draw in purple. looks curvy. We are currently only worried about the basic shape of a parabola, but if you want to be more accurate, we can, and that will be a later unit where we get into parabolas. It moved to the right by 3, change the sign, keep the sign, 3, 1. So it moved right by 3, up by 1. So let's move this to the right by 3, 1, 2, 3, and up by 1. And then we curve it. We are not stretching it vertically or horizontally. This would be g of x, and f of x would be in the purple. All right. The next graph that we have, this one's going to be a little bit harder. F of x is going to be a negative 2, 0, and that would be to the left by 2, and it is a basic absolute value, but just shifted to the left by 2. So it has the slope of up by 1 over by 1 and mirror imaged on the other side. The g of x is going to be stretched vertically. It is going to be technically with the negative x there flipped over y-axis, and then it is going to be up by 1, but how much is it going to go to the left or to the right by 2? Well, remember, if you can't remember, what to do when there is a b value is to set it equal to 0. So if we set negative x plus 2 equal to 0, we would subtract 2. We get negative x equals negative 2, and then that means that x equals positive 2. If you do remember, what you do is you change the sign and then divide by negative 1. Well, if we change the sign of 2, we end up with negative 2. Divided by negative 1 makes positive 2. So this vertex is actually going to be at 2, positive 2. Change the sign, then divide by negative 1, positive 1. Okay? So that is the vertex of g of x. So we are going to go to the right by 2 and up by 1. And it has the stretched vertically by a factor of 3. 1, 2, 3 over by 1. There we go. 1, 2, 3 over by 1. There we go. There's g of x. Okay? So what happened here? Well, how much did it actually go to the right by? Compared to the origin, it went to the right by 2 and up by 1. How much did it go to the right by compared to f of x? Well, compared to f of x, it went to the right by 1, 2, 3, 4, and up by 1. So really, compared to f of x, it went to the right by 4, not right by 2. All right? So it's all relative to where you're actually looking at. Number 1, translated up by 4 units, stretched vertically by a factor of 3. So these we are going to write the equation of g of x given the transformation. So if it's translated up by 4 and stretched vertically by a factor of 3, that means that g of x is going to have to be stretched vertically, x squared. It has a vertex of 0, 4. That's why I didn't write anything with the x. And then plus 4. Ta-da! What about a horizontal compression by a factor of 2? All right, so we have g of x. If it's a compression horizontally, remember a compression horizontally, the b value, which is the number right next to the x, is greater than 1. So that means that we would have a absolute value, then the 2, then the x. If it is reflected over the x-axis, if we want to reflect it over the x-axis, that means that the entire function would have to be negative. So what you could do, there's one of 2 ways to do this. If there's more things, it matters even more. So what you could do to reflect it over the x-axis, this is currently just the compression. Now, if we want to reflect it, we could do negative g of x is equal to absolute value of 2x. And then we can divide everything by negative 1, which is why g of x would equal a negative on the outside, then the 2x. If there was anything over here, that plus 0, that would also have to change the sign for it to reflect it over the x-axis. All right? So that's why when we have this one, when I wrote the note, so we changed the value of a and changed the value of k. You got to distribute that negative. All right. Let's talk about number 3. Reflect over the y-axis, translate left 3 and up 2. So reflect over the y-axis means that we would have to take the g of x, and it would have to be a negative x here. Let's focus not on the left 3, but the up 2. The up 2 is unaffected. but the left by 3, typically we change the sign here, but because there's a negative here as well, we need to actually change it twice. Remember how you can set it equal to 0. If we set negative x plus 3 equal to 0, if we subtract 3 and divide by negative 1, you get x equals positive 3. Nope, negative 3 divided by negative 1, it'd be positive 3. Left by 3, minus. So be careful with that. I almost messed up. If we do negative x minus 3 equals 0, add the 3, negative x would equal 3, x would equal negative 3. We want it to go to the left by 3. So typically it would be a plus here, but because we wanted it to be reflected as well, that's why it's negative there. All right. A few more. Reflected over the y-axis. If we want to reflect over the y-axis, that means that the x value would need to be negative. Translated left by 4 and up by 2. So again, we're doing g of x. G of x is equal to negative x. Left by 4 would typically be a plus, but because we already have the negative, it's going to be a minus 4. Up by 2. Ta-da! You could also, because this is a line, you could also get away with writing negative x, minus 4 and plus 2 plus 2. Both of these would be considered an answer. Minus 4 plus 2 is negative 2. All right. Next one, we got to translate it to the left by 4 and vertically compressed by a factor of 4. Okay, so if we want to translate it to the left, it's already moved to the right by 3. If we want to translate it to the left by 4, we need to go 4 to the left of this. Well, if we are currently at 3, 0, if we go 4 to the left, the new vertex would be at negative 1, 0. So let's graph and write that equation. It would be y equals x, change the sign, plus 1 squared. I've left out the 2 because if it's compressed vertically by a factor of 4, compressed being the key word, that means that we do not want to make it bigger and more skinny. We actually want to widen it out. If we want to widen it, by 4, we would really need to be multiplying by 1/4. Okay? So if it's multiplying by 1/4 and there's already a 2 here, 2 times 1/4 ends up being 1/2. We end up with 2 over 4, which is 1/2, which is why I'm going to throw 1/2 in here. You need to be careful with the compression and the stretching because a vertical compression is the same thing as saying a dilation or a stretch horizontally in a way. All right. Translate to the right by 6 and up by 3. So this one, I want you to be careful with the 2x squared. There are a few different ways we could deal with this. We could first start by recognizing that f of x is really no different than saying 4x squared if you square both of these. Okay? And if you recognize that, then it becomes a lot easier to do g of x, which would be 4. Right by 6 would be x minus 6. Up by 3. And that would be one version of the answer. Okay? Not the only version of the answer. The other way we could deal with it is if you were to take the original, which would be 2x, and you have the squared there. You could still put the plus 3 on the outside, but if we want this to be to the right by 6, then we need to change the sign, but we need to be very careful because what we put here needs to be to the right by 6, and we need to put a number here that when we divide by 2 would be to the right by 6, which would make that a 12. So let's make sure 2x minus 12 when we set it equal to 0 would be 2x equals 12 and x equals 6. Okay, so there are two versions of the answer here. I like the top one more, but you might use the bottom one. Both of them are correct. Until next time, everybody, stay positive, and I will see y'all later. Bye.